Hi everyone, it's me, Carolyn, and in this video we are going to actually be doing some hypotheses testing for a population proportion. So we're going to be picking at one of our parameters and learn very roughly how to go through that hypothesis testing procedure. In the first section, we just kind of got introduced to how to write our hypotheses and kind of how to write a conclusion very briefly. We'll do a few more here. I don't do a ton of examples because they are quite long and lengthy. I will be doing this one using both StatCrunch and our tables. Because I do find value, again, in remembering how to use our tables and things like that. But StatCrunch is at our fingertips in this course, so I want to also make sure that I show you how to utilize that. So the first thing I'm going to do is share my screen, and we'll get into our guided notes so that we can look at the steps that we go through. So this is section 10.2, and I did want to put at the top that it is hypotheses test for a population proportion. So we're going to be looking at our population proportions. And the first things, there are some things we need to check before we can really go through our process. The first question we want to make sure is that we have a simple random sample. Now, we aren't going to be doing the experiments themselves. We're not going to be going and gathering these samples. So that first thing is will be done for us. And we will kind of assume that it was done correctly and done using a simple random sample. We want to make sure that our NP and 1 minus P is bigger than or equal to 10. Again, we will actually check that simply because it's an easy calculation for us to do. Also, the last one is to make sure that N is less than 5% of the population, just to make sure our individual samples are independent from one another. Again, we will assume that is done correctly when the sample was created. So those two pieces we will not check, but we will look at part verify step 2. Okay, there are 5 steps to a hypotheses test. Some books, some textbooks may list 6 because they do break number 5 up into 2 pieces. And that is just discretion of the author and things like that. So it really doesn't matter. There are steps. This textbook tends to list out 5. And I usually just follow the 5 as well. I've done 6. It really doesn't make a whole lot of difference. But the first thing we're going to do is we're going to have to determine that null and alternative hypotheses. And we're going to write those out. Now, we did get some practice, very little practice in that last video in 10.1. But we're going to continue to do that here. The second one is to select the level of significance, the alpha level. Remembering alpha is the probability of that type 1 error. We want that to be kind of small. Now, this level for us will actually be determined in our problems. In the real world, that level is going to be set by statisticians. One of the most common alpha levels is 0.05, so 5%. And sometimes, depending on if it's more of a life-threatening type of thing, they might make it even smaller because they don't want to make changes in the status quo unless there's going to be some significant benefits for doing so. And if it's a life or death situation, we really are cautious. Okay, the third step is to compute what we call the test statistic. This test statistic is based on the sample that we calculate, we gathered. And you may recognize some of this, looks very familiar to us. It is a Z, so that means our normal. Since we verified that NP, 1 minus P, was bigger than 10, we can use our normal curve. So we will have a normal test statistic. It's a standardized test value based on our sample. So this P hat, that's our sample piece. This P0, that's going to be the value that's in our hypothesis. So that's the status quo type piece. And then we'll put that in here as well. So we will compute this test statistic. Now, this step here is different for every type of hypotheses test. So the step one is always the same, the null and alternative. They may look different from one type to another, but we still have to write them. Step two is the same. We have to find that level of significance. Step three is calculating a test statistic. For these problems, we're talking about the population proportion. This will be our test statistic. Step four, we have some options, depending on what you have access to. Now, in the days of tables alone, finding critical values was probably the easier of the two to do. Nowadays, with all the technology out there, finding the p-value is very easy to do. I will go through both methods in this video as well as the next videos. In future videos, I may back off slightly and not do the p-value using tables, because that's kind of and you'll see it in the next video, it's not as pretty as it is for finding critical values, but we will do both. And then step five is to make our decision to reject or not reject that null, and then write our conclusion. A lot of people in other textbooks will break this two parts up. Step five would be make the decision, reject or not reject, and then step six is to write the conclusion. But we do need to make our decision, and we do need to write the conclusion, no matter what type of hypothesis test this is. So the biggest difference between one type and the next type is a little bit about the null and alternative. They may look slightly different, and then our test statistic formula may look different as well. So let's do some. Oops, I got a water spot down there. Sorry about that. And we'll go through a couple examples. So, and I will be using some StatCrunch there to help us a little bit. So I'm going to kind of say, okay, we got Nexium is a drug that can be used to reduce acid produced by the stomach and heal damage to the esophagus due to acid reflux. Manufacturer claims that more than 94% of patients taking Nexium are healed within 8 weeks. The clinic wants to basically figure out, is that true or not? So they test 224 patients, and they found that 213 were healed within that 8-week period. Is there enough evidence to support that manufacturer's claim? And our alpha level of 0.01. All right, so we're going to go through our 5 steps. So step number 1, and I will actually write these out for us. Step 1 is to write those hypotheses. So we have our null hypothesis and our alternative hypothesis. Our null hypothesis is that equal statement. We are talking about a population proportion, and it's that 94% that they talk about. Excuse me. Our alternative is kind of what we're trying to find support for, and they're saying that more than, so that's going to be greater than 0.94. So there's our step 1, is to write those two hypotheses, the null hypothesis and that alternative hypothesis. Step 2 is to determine the level of significance. Well, the level of significance was already given for us, so I usually just make sure to point it out and write it down in my steps. There's my step 2. Step 3 is to calculate our test statistic. Now, before I even go there, I probably should make sure that I can use my test statistic. So I'm going to first check, make sure that my n times p, my 1 minus p, are bigger than or equal to 10. Just to make sure. So we had 224 people. Okay, and the p that we use is the status quo number that we have. So that's going to be the p that we use. So we're going to use that 0.94. But this was our sample size. That was 224 patients that they looked at. Again, we should check 3 pieces. We're going to assume that the clinical trial did a good job of selecting a random sample, made sure that the sample size was not too large, and so forth. So we're going to get this value here. crank out our calculator. This is actually 0.06. That'll help me out a little bit. And I get that this is 12.6, which is bigger than or equal to 10. So we're good to go on all of this stuff. So we can use our normal curve. Our test statistics. Sometimes people test value is going through our formula. So we're taking that at minus our P0 all over the square root 0, 1 minus P0. Okay, now our P hat, that is the value that we got from the actual sample. So that is our 213 out of our 224 patients. Our P0, the reason we put a 0 in there is because we're looking for the number in our null hypothesis. So that 0.94. Divide that by square root 0.94, 1 minus 0.4, all over 124. Then we get our calculators. This number here is like 0.95, 0893. I get this value here, 06. So I would subtract, I would probably get this value in my calculator, subtract that 0.94. So 213 divided by that 224 minus my 0.94, get that value, divided by square root 0.94 times 0.06 divided by 224, close the parentheses, hit my equal button. And I am going to round it to, I don't know, let's see. There's a couple digits for you. So you can kind of double check. So that is our test statistic. Now remember that this is a normal curve, okay? And this is our standard normal curve. So here's our 0 sitting in the middle. And our 0.68, I don't know, is probably here or so. I don't know, it could be further on. Scale is not mandatory. This is our Z value, that's our test statistic. So step 4, what we're gonna do is we're gonna determine, is this number significant? In other words, is it far enough away from the normal to prove that it is in our, what I like to call the critical region. So I'm going to put in my picture here. Okay. Alpha is kind of looking at our critical region. Notice we are only looking at greater than. So we're only looking up here in this direction. This is sometimes referred to as a one-tail because we're only looking in one direction. And this time we're looking above. And we're actually looking at the right tail. So it's a one-tail test to the right because of the greater than symbol. We put our alpha into the critical region. So that shaded region is the critical rejection region. So we need to kind of know, does this guy fall in that spot? And this is where step 4 gives us 2 options. So step 4, what we can do is find our critical value, which would give me this value right here associated with the 0.01. Okay, that's finding our critical value. Or we can find the p-value associated with this. Okay, so I'm going to kind of do it both ways. So if I'm looking for the critical values, I'm going to look at here, my critical value. I'm going to look for that value that has this 0.01 up here. So if this is 0.01, that's 1%, 99% here. So again, if you're looking at the Z table, and I'm going to show you the other table, we can find it a little faster. All right, we're looking for 0.99. Well, here's my 0.9901. So this one's probably pretty close. So my 2.33. So my critical value is 2.33. Okay. I want to remind you that if you're looking at a T table, so remember our T table from chapter 9, the Z values are located at the bottom. Okay, and this is the area to the left. So if I wanted to just look up at 0.01, there's my 0.01, and go all the way to the bottom, I also get that 2.326. So if I use that table, it's going to be a little bit more accurate because it gives me 3 digits versus the 2 digits from the Z table. Okay. So that's how we find our critical values. To find our p-value, what we do is remember that this is a Z. So we have that our Z value is 0.68. We're going to turn that into a probability. So the p-value is the area in the same direction that we're looking, associated with our test statistic. Okay, so I'm going to take my Z table and I need to look up 0.68. So 0.68, and I get 7517. 0.7517. But remembering the table gives us from that point down, we have to actually subtract from the 1. So it's been a while since we've done this. So our p-value is this number right here. So there's our p-value. And here's our critical value. Okay, so now what we have to do is decide. So that's step 4. We found our p-value, or we found the critical value. You do not need to do both steps. You only need to do one. Technology will give us both. So I'll show you that in a moment. And then what we need to do is in step 5, make our decision and then write our conclusion. Okay, to make the decision of to reject or not, what we have to remember is, does this fall into our critical rejection region? So we can do a couple of things. If I look at a number line and I look at where that, here's my 0, here's my 0.68. My critical value, I'm going to put that on the same piece. Here's that 2.326, which kind of gave me the boundary for that. This is not inside that critical region. So we kind of want to know, where is this located? This is not in the critical region. 0.68 is not in the critical region. Abbreviating that. So we will fail to reject. Or do not reject, I should say. Do not reject. If we compare our p-value, we will also look at our p-value, which is that 0.24. For us to reject, it has to be smaller than alpha. To reject, p-value must be smaller than the alpha level. Ours is not. Notice 0.24 is much bigger than that 0.01. So again, we will not accept. Okay, which means our conclusion. So if I go back to my pieces here, my original hypotheses, we are not rejecting this, so we aren't really supporting this. So basically, we're going to say that there's not enough evidence to support this. There is not enough evidence to support that more than 94% of patients were healed within the 8-week period. Sorry about my sloppy handwriting. Okay. And you'll notice that we did, our p hat was 0.95. What it was not big enough to say more than 94. It's too close to 94 to say that it's more than 94. So that's kind of what happened. I do want to go to StatCrunch and show you how we can get these same pieces here. So I'm going to switch my screen to looking at my StatCrunch. Okay. And I will probably do the next example both ways as well. All right, so StatCrunch. So again, what we're going to do is in StatCrunch, we're going to go to the stats. We are doing proportion. So because we're testing our hypotheses on our proportions, we are looking at a single sample, so a single P. We have summary. So we don't have the original data, so we have our summary. All right, so this is where I'm going to be putting that information about our sample. So we had that 213 out of our 224. 24. Okay, we are doing a hypothesis test. Notice we did this one also we did this test or use the same screen for our confidence intervals. Our P that we're testing it is 0.94. So we're setting up our hypotheses. There's our 0.94. And here it gives us a drop-down menu to pick which one we want. And we were doing greater than. Okay. I want to also show my critical values. I'm going to put in my alpha level, 0.01. And then I'm going to hit my OK. This is going to allow me to get both the p-value and the critical values. If I didn't click this button, I would not get those critical values. But I kind of want to verify both methods that I showed you. So I'm going to hit compute. And we'll bring this over. You'll notice here's my 213 out of the 224. There's that p hat that we talked about. Here is that test statistic, that 0.68 that we had calculated. There's the 2.32 something that we had found. That was our critical values. And here's our p-value, that 0.24. We had 5.1. That's due to some of the rounding and the fact that the computer system is a little bit more accurate than our tables. So again, we can get all of that value right from here. We don't have to do all of the grunt work. Okay, and in the next example, I am going to use StatCrunch just to speed things up a little bit. I'll still go through our 5 steps. I'll still draw all those wonderful pictures, but I'm going to come here to get all the details. So I'm not going to spit out the actual formula. I'll set it up, but we'll get to the next piece. All right, so let's come back to our guided notes. And we'll do another example. All right, so here's another example. Let's see if I can get it. There we go. All right, so we have in 2002, 47% of K-12 were satisfied with educational system. Okay, fine. A recent poll found that 337 of 12 or 13 parents were satisfied. Is there enough evidence to show that the attitudes have changed? Okay, so we're kind of looking at now versus back then. So again, I'm going to be going through my 5 steps. I will verify, first of all, just to make sure that we can go through all of this. So I'm going to do my NP, but I need to put my hypotheses for what P is. Okay, so my hypotheses are, we're thinking the proportion that was 40. We're just wanting to know if it has changed. The change is not 47. And this is going to be the P that we have. So our N is at 10, 13. P is 0.47. 1 minus P. And I'm going to calculate that value. And I get 0.3, which is way more than 10. We're good to go. Okay, so step 1 is writing my hypotheses. We did that. Equal to 0.47, not equal to 0.47. Step 2 is finding that alpha level. Well, they always tell it to us. That's an easy step for us. Step 3, which I'm going to use StatCrunch, and I'll also do step 4, and I'll go to StatCrunch and get those pieces. But step 3 is getting that test statistic. And again, it is a z-value. So we'd be putting our p hat minus our p0, 1 minus p0 all over n. Putting in our numbers, we found 337 over 1013 minus that 0.47. 0.47, 1 minus 0.47, all over 1013. Okay, I do want to draw a picture when we come back, but I'm going to go and get StatCrunch here and get all my pieces. So I'm going to get my test statistic, and in step 4, I'm going to get my critical value, and I'm going to get the p-value. So I'm going to get those pieces, and then we'll come back here and draw some pictures. Also, while I am there, I'm going to get my 95% confidence interval. See why at the end, but I'm going to kind of go to StatCrunch to get all of that information just to save us some time. So I'm going to go back to StatCrunch. Here we go. And I'm going to go to stats. We're doing proportions. We're doing a 1 sample with summary. My data was here 337 out of my 1013. Make sure I type this in. Hypothesis test, we're doing 0.47 versus not equal to. Okay, it does not allow me to do 2 of them at the same time. I really wish it did, but it does not. I'm going to get my critical values. My alpha level is 0.05, and I'm going to hit compute. All right, so I'm going to kind of get my numbers from there. And let's see here. I have my sample proportion is there. There is my test statistic. It's a negative 8.7572. My critical value, I'm going to just put 1.96. And my p-value, they tell me, is smaller than 0.0001. Okay. While I am here, I also said I wanted to get my 95% confidence interval. So again, proportion stats, 1 sample with summary. And we had 337 out of our 1013 confidence interval. And I do want a 95. And the reason I chose 95 to kind of coincide with that alpha level. So I'm going to hit compute. And I'm going to write this down here too, that my lower limit is 0.30366, and my upper is 0.36169. All right, and I'm going to go back to my guided notes, and we'll draw some pictures so we can kind of see all the information that we have. Okay, so I've got all my pieces here. So from StatCrunch, they cranked out this number. Yes, you could do it with a calculator. StatCrunch was a lot faster than I was. Critical value, I'm going to draw a nice picture here. If you were doing this one, notice we did a equals versus not equal. So when we're looking at this one, we're kind of looking both directions. We're not looking greater than, which would be to one side, or less than, which would be to the other side. We're doing not equal to, which means we're looking in both directions. Okay, so when we look in both directions, we refer to this as a two-tailed test, going in both directions. And so we have two critical values. So here we would put that alpha in both pieces. So this would be like alpha over 2 here, which is 2.5%, and 2.5% here. Their alpha was 0.05 or 5%. We're going to split it in half. And we would be looking for our critical values that coincide to that alpha level. And so we'd have that 1.6, and we also have a negative 1.9 to allow us to go either direction. Now the picture we have, the p-value, that corresponds to so that negative 8.7, that test statistic, that negative 8.7, that's way down here somewhere. Negative 8.75. Okay, our p-value, since we did do a two-tailed test, is finding the probability in the two tails that go with that. So if I had also an 8.75 up here, it's that value on both. All right. Okay, so now we have to get done our step 3, we've done our step 4, we have to do step 5, which is just to make our decision. So is this a significant change? Notice this value, we also had that on Excel as well. Our p-hat was quite different than 0.47%. It was quite a bit smaller. It was like 30-something%. But was it small enough? Was it a big enough change to say, yes, they've changed? And the way to tell that, again, the two ways we do it is we look to see, is that test statistic in those shaded regions? So here's my negative 1.96. Negative 8 is way down in here. So yes, it's in that critical region, in that rejection region. Or we look at our p-value. Here's our p-value. And is that smaller than our alpha? Well, this number is smaller than this, which is obviously smaller than 0.05. Is smaller than our alpha. Or our test value is in the critical region. So we will reject. Okay, in other words, in the case of innocent versus guilty, we're going to say that they're guilty. So there is enough evidence. There is enough evidence to show a change, and I'm just going to write this shorter, in attitudes. So it's no longer, or a change from that 47%. You can get a little bit more wordy here if you'd like. This is probably not my strong suit of writing those conclusions, but you do want to make sure to write it in reference to what we're talking about. So just saying that there's enough evidence to reject H0, that's not going to be what we want to say. We do want to go back to the original question at hand. Is there enough evidence to show that that there has been a change in attitudes? Yes, there's enough evidence to show that those attitudes have changed, that they are no longer 47% of our parents being satisfied. Now, we can't say it's one way or another, not less than or greater than. All we have tested is if it was equal to versus not equal to. Okay. Since we were doing a two-tailed test, We could have done, like I did, I said we could have created that confidence interval. The confidence interval basically looks at, kind of centers around your p hat and puts up an upper bound, which we found here to be 0.36, and a lower bound to be 0.30. I'll put some more digits in there. Okay, so based on that sample, we are 95% confident that the true proportion is within there. Now, if you go back, our original assumption was that the proportion was 0.47. So 0.47 is not in this interval. Is not in our 95% confidence interval. So again, since it's not in there, it means that it's outside. So based on this sample, something has changed. It has, I'm gonna guess, shifted down. So this is another way to kind of check to see if we could reject. So there's another possible way to do that, but it only works if it's a two-tail because we go both directions. Right? You can play a little bit with a confidence interval to look one way, but it becomes a little bit more complicated. So a lot of times I still just go through my 5 steps, finding my critical values and my p-values. But again, I can verify it one more time. Notice the 0.47 is not in that confidence level, that 95% confidence level. So yes, rejecting does make sense. Okay, so that kind of concludes this piece of hypotheses testing for proportions. In the next video, we will be looking at hypotheses testing for the mean. Again, a little bit more complicated because if you remember our confidence intervals, we used a t-curve, those t-distributions. So it's going to be a little bit harder, but again, we have StatCrunch, so we'll be using StatCrunch to get most of our pieces for us, which help speed things up a little bit. But we need to understand the ideas behind everything. Hence the reason I like to draw my little pictures and look that way. So I'm going to stop here and I'll see you guys all in the next video.